This function is a quadratic relation, and it's a quadratic relation that's been rotated, so it's a parabola at an angle. So it's an implicitly defined function, and we want to find the derivative so that we can find the slope at the vertex 0, 0. So when I differentiate this, I'm going to again differentiate implicitly, means which I'm going to differentiate the x's normally. Here I have a product function, so I'm going to make sure I use the product rule here. So again, I'm going to differentiate x normally. So I just end up with the y, undifferentiated, plus I'm going to not differentiate the x, and then differentiate the y. Since y is an embedded function, I need to apply chain rule here. So I get y prime. So that is my product rule here. So then I'm going to differentiate the y, the outside first. So differentiating the square, I get power 1. But because y was embedded, I need to apply y prime. So every time I hit y, I need to apply y prime. So here again, I hit another y, so I have to apply the derivative y prime. Plus 1, don't forget the 1, and that's going to be equal to 0. Okay, so now I've got the derivative. I've got generated my y primes. I just need to group my y primes together. So I want to group that y prime with that and that. So I'm just going to do that here. So I'm going to, first of all, expand the brackets. 2x plus 2y plus 2x. And again, I'm just going to keep track of my y prime. Y prime plus 2y, y prime, minus y prime, plus 1. And that's equal to 0. I'm going to factor my y prime out, and I'm going to group all those terms. So 2x plus 2y minus 1. Don't forget that minus 1. And then everything else goes to the other side. So all these terms here, these terms end up on the other side of the equal. So this becomes negative 2x minus 2y minus 1. Now, unfortunately, these expressions are almost similar, but there's no common factor involved here, so I can't really simplify that. So I'm going to end up with y prime, or I'm going to write this as y prime as a function of x and y, so I need both the x and y coordinate for this, is going to be equal to negative 2x minus 2y minus 1, and that's going to be all divided by 2x plus 2y minus 1. Okay, so I want to find the slope at the vertex, and looking at the slope of the vertex, it looks like, just eyeballing it, it pretty much looks like it's 45 degrees. So let's calculate the slope of the vertex. So y prime at, let's put in the vertex point here. It's going to be 0, 0. This is going to be an easy coordinate to calculate. So when I put this in, I'm going to end up with negative 1 over negative 1, and that's going to give me a slope of positive 1. So there's my slope. Okay, and then that looks definitely like positive 1. We can look at part B. We're going to do the same thing. We've already got the derivative, so all we need to do is find the slope at x equals 1. To do that, we need a y coordinate. So to find the y coordinate, we have to use the original equation, and we're going to plug in x is negative 1. So I'm going to end up with, I'll do this over the side, so I'm going to end up with negative 1 squared plus 2 times negative 1 times y plus y squared minus y minus 1, and that's going to be equal to 0. So I have a quadratic in terms of y, so y squared. I'm going to group my y terms, so I have negative 2y, negative y, so I'm going to get negative 3y, and then that's going to be 1 minus 1, so that's going to be equal to 0, so I get that equation equal to 0. So I'm going to have a y coordinate. when I factor this, my y values for x equals -1, I'm going to have a y coordinate at 3. So I guess if I extend this graph up here, it's going to be at y equals 3. There's a point way up there. Okay, but there's also a coordinate at y equals 0. So when x is -1, y is 0, we're just going to find it for that point there. Okay, so let's find the slope equation for that, and then we can find the slope, and then we can write the equation for that. So the slope, I'm going to plug that into my slope formula. So it's going to be at x is -1. So -1, y is 0. And plugging that into my slope formula, I'm going to get, let's see here, it's going to be +2 -0 -1 in the numerator. Okay, it's going to be -2 plus 0 minus 1 in the denominator. That works out to be 1 over -3. So we have a slope of -1/3. So then it doesn't ask for this, but we're going to write the equation of the tangent line. So the tangent line equation is going to be -1/3. And then we'll plug in the x and y coordinates. So it's going to be x plus 1 and plus 0 for y. So that's our point slope form. We don't really need that plus 0, but that's our point slope form of the tangent line. And that's going to reflect this tangent line that I'm going to just sketch in here. So it's going to have a slope of -1/3, and that's going to be that line there. And we can graph this to confirm this.